Hello guys, my name is Kwan and I'm here to tell you about my pressure sensitive gym equipment. For my table of contents, this will include an abstract, an introduction and background, project objectives, a methodology which consists of a phase 1, hardware architecture, phase 2, a device in action, product results and discussions, a project deliverables, a project plan, which is a Gantt chart, and a project budget and project justification, and finally with a problem and challenge. Then I will summarize this with a conclusion and include my references. So for my abstract, what's the issue with exercising? Sometimes people can get injured, not have proper form, or have some kind of muscle imbalance. Or sometimes people don't even want to exercise in the first place because they don't know where to start or don't have any motivation. Well, the bad thing is if someone does get injured, they won't be able to work out and will have some kind of long-term injury depending on the kind of damage they get. So for the main objective of this project, it is to develop a pressure-sensitive gym equipment that is intended to aid in lifting weights evenly and in a controlled motion. When exercising, the information is sent to an app that records the data to provide feedback and easy-to-understand diagrams and graphs. The outcome of the project was to ultimately help gym goers lift weights evenly to maximize muscle gains and reduce the risk of any kind of injury. So the introduction and background. Working out provides many benefits such as weight loss, muscle and bone improvement, increase in energy levels, a stronger immune system, and much more. The pressure-sensitive gym equipment was designed to help record muscle imbalances, reduce injury, and maximize muscle gains. It also provides you with different workouts and diet plans to reduce the chance of plateauing. Fixing muscle imbalance is important because if it's not fixed, it could lead to some kind of potential injury. The project objectives were to reduce the size of the device while developing so it fits more comfortably while in use, have the device only work when lifting weights, making it energy efficient, and make the connectivity easy to connect to mobile devices. And also, the third one is to make an app that makes interpreting the data easy to understand, and this can be measured through ratings and reviews on the App Store or Google Play. Finally, the last objective was to reduce lifting imbalances to at least 7% of total weights lifted within 8 weeks of using the product. For the first phase. The first phase of the project was designed on 2 phases, and the first phase is focused on hardware design and manufacturing. The goals of the first phase were to find the relationship between weight and voltage for the force sensors in order to make sure the Bluetooth, voltage reader, and the force sensor and battery work together. Making sure the electronics fit into the shoes and gloves to ensure comfortability, and aligning the sensors to make sure they get the most accurate readings as possible. For the first phase, when a battery is connected in series with a resistor, and when a voltmeter is placed between, a voltmeter occurs, or a voltage drop occurs. When weight or the force is applied, a larger voltage drop will occur. This will be used to find the relationship between weight and the voltage. The electronics are placed on the palms of the gloves to keep track of the force used by the hands and placed on the soles of the shoes to track the force by the lower body. The sensory alignment was a trial and error and will depend on the individual. For my hardware architecture here, you can see that I have a 3.7 volt LiPo battery in series with the force-sensitive resistor and the voltmeter. Now, when any kind of force is picked up from lifting weights or any kind of pressure is felt, the force-sensitive resistor will pick up that force and transmit the data to the voltmeter because a voltage drop occurs. When that voltage drop occurs and the voltmeter picks it up, the data is then sent via the Bluetooth module, and the module sends the data into the phone. Now, the second phase was focused more on app development and testing the product. The goals of the second phase were to display data from sensors in a user-friendly way by showing out graphs or visualizations to make it easy to understand, testing the product by doing several different exercises, and to receive user feedback from the app. For displaying the data, information is sent to the app and it displays the amount of force used during the set and records which muscle group was used more. Any kind of muscle imbalance. The data is then displayed on pie charts and line graphs that compare multiple muscle groups. Exercises such as the bench press, squat, deadlift, overhead press, and clean and jerk will be used for testing because these exercises are done by athletes for maximum muscle growth. And the last step is to receive user feedback in the app's GUI. This is achieved. This was achieved by releasing the app on the App Store and Google Play and asking people what they liked and didn't like about it, as well as what could be improved. For the device in action here, we have a 225-pound barbell. So the bar weighs initially 45 pounds, and the plates each weigh 45 pounds. So that's 225 pounds in total. And here, in this case, the individual who is lifting this weight up weighs around 160. As you can see, the 200 pounds and the 185 add up from the 160 plus 225, which adds up to 385 pounds. And in this case, since the individual is standing with his hands, the 115 pounds and 110 pounds come from the barbell, since he's trying to pick this bar up in action, and he's trying to perform a deadlift. So when the individual goes to pick up the bar, because when you deadlift, you're supposed to keep your back straight and lift your legs, the individual here on his right foot is showing to have more force than his left foot. So it's showing his right foot is a lot stronger than his left foot, which indicates some kind of muscle imbalance. And when the individual is picking up the bar, his right hand is stronger than his left hand by 5 pounds, making it more difficult for the individual to pick it up. So in this case, his right hand and his right foot are a lot stronger than his left hand and his left foot. And the device would pick that up and transmit it via Bluetooth. For the project resulting discussion, after building the project, the outcomes were a success. When athletes used the product, they noticed a difference in improving muscular imbalance and noticed an increase in athletic lifts. The product also reached its goal of being on when exercises were performed in order to save battery, as well as connecting to wireless devices easily. The data was also very easy to understand on graphs and charts based on the feedback from the App Store and Google Play. Users have also stated that the device fits comfortably in the gloves and shoes when working out. The overall agreement is that the project completed all the stated objectives and is successful. For the product deliverables, since the project met all of its objectives, companies would like to purchase the product and market it. In order to market the product, it would be advertised online, on television, in stores, and in magazines. For online marketing purposes, it would be focused on websites focused on exercising and weightlifting. On television, it would be marketed on sports channels and any fitness channel. For marketing in stores, it would be towards sporting centers where athletes can purchase athletic equipment. For the project timeline, the duration took around 15 weeks for the first part and 15 weeks for the second part, making this whole total of 30 weeks. So for week 1, it is focused on testing and integrating the sensors and takes up 5 weeks. These are all for phase 1. The second part is connecting the Bluetooth module, which takes around 3 weeks. The next step is to insert electronics into GymWare, which takes around 7 weeks. And sensor alignment and calibration takes around the next 6 weeks. And this is all for the first part. For phase 2, it is focused more on app development, which takes around 10 weeks. Device testing, which takes around 2 weeks, and any final adjustments or improvements will be around 3 weeks, making this a total of 30 weeks. For the project budget and justification, the total will be $316.82. It will consist of 7 parts. It will consist of a FlexiForce pressure sensor, a Bluetooth module, workout gloves, flat sole shoes, a LiPo battery, a voltage sensor, and 20 AVG wiring. The FlexiForce pressure sensors are sensors for the hands and also for the feet. The Bluetooth module will be used to transmit the data. The workout gloves will be something where the module can store its place in. Also, as well as the flat sole shoes. Flat sole shoes are used for working out, usually since they're flat soled. They won't cause any kind of movement in between workouts. The LiPo battery will be used to charge devices up. The voltage sensors would also be used to pick up any kind of reading, and the wiring will connect it all together. For the project budget breakdown, here's a pie chart of everything, with most of the cost being in the FlexiForce pressure sensors, taking around 63%. The 20 AVG wiring takes up around 2.4%. The voltage sensor takes around 1.2%. The LiPo battery takes around 5%. Flat sole shoes take around 17.4%. The workout gloves take around 4.1%, and the Bluetooth module takes around 6.9%. For the problems and challenges. The problems and challenges for this project are calibrating and aligning the sensors along with developing the app. When working out, sometimes the sensors would slip off the gloves and lose calibration and make the data inaccurate. This usually occurs with the clean and press instead of the other exercises because this exercise involves a lot of movement and can shift the sensor out of the hand. In order to fix this problem, the sensors will be woven in between the gloves to prevent them from moving and falling. With the app development, the old problem is displaying the data on the charts and graphs properly. In order to fix this problem, I will recheck the code and make sure it works properly. If the code doesn't work, it will be rewritten and double checked to make sure it works. In conclusion, this project helped athletes and regular people reach their potential and have a healthier lifestyle. The equipment was designed to reduce the risk of injury, fix muscle imbalance, and maximize muscle development with workouts and diets. The product increased efficiency in workout, and with the Gantt chart, the goals were reachable based on the allotted time period. There were a few issues but could be fixed within a few weeks, and this product is great for people who are looking to get into shape and want to change their lifestyle. And for a little short story, I really got into working out when I was a senior in high school, starting out in 2016, around February. I've been working out for around 3 years, and I've seen a big difference. And I'm hoping this product could also make a difference for some individuals, because starting to work out, I wasn't the strongest guy, and I wanted to change that up a little bit. So I just kept putting the hours in, seeing results, and I was pretty amazed by that. But hopefully with this product, individuals could see results faster and get a better lifestyle enjoyment out of it. And for my sources, here are the references I used for this project.